My name is Michail Stamatakis, and I'm Associate Professor at the Department of Chemical Engineering at UCL. My research is within the areas of computational catalysis and material science and aims towards elucidating the dynamics of physical and chemical processes on the surfaces of heterogeneous catalysts at the molecular level. This is of special interest in chemical engineering, in which catalysts are used to accelerate chemical reactions or drive them towards desired products. Catalysis is therefore at the heart of all chemical technologies, including, for instance, the manufacturing of pharmaceuticals, fertilizers, polymers, the cleaning of water and air, as well as the storage and release of energy using batteries or fuel cells. In my group, we develop and use multi-scale computational methods to model, simulate, and predict the properties of materials for such practical applications. In this context, the development of kinetic Monte Carlo code ZACROS has been a flagship project in my group for over 8 years and has been a key component in our efforts towards elucidating the intricacies of catalytic behavior. The Research Software Development Group, RSDG, at the UCL Information Services Division, has been instrumental in the development of ZACROS. It's worth noting that ZACROS was one of the first projects that the group worked on when it was founded back in academic year 2012. That project introduced shared memory OpenMP parallelism to ZACROS, enabling simulations on some difficult systems to complete up to 10 times faster when using 16 processors. More recently, we have tackled a much more challenging problem, introducing distributed memory parallelism in kinetic Monte Carlo simulations of very large domains. This entails decomposing the domain into subdomains and assigning each one of them to a processor, which is allowed to privately execute events at the interior of its subdomain. However, when events happen at the subdomain's boundaries, they must be communicated via messages to processors that are dealing with the neighboring subdomains. Since the execution of events occurs asynchronously among processors, it may happen that a message refers to an event that should have already been executed in the past of the neighboring processor's history. This triggers a causality violation that needs to be addressed by rolling back to a time earlier than the message's timestamp and re-simulating the wrong history segment. Of course, when doing this, more causality violations can occur because the history segment being corrected may include messaged events that happened at domain boundaries. Thus, one causality violation may eventually lead to a cascade of violations that need to be corrected in an orderly fashion so that the correct simulation history is finally obtained for the entire domain. To address this challenging problem, we implemented into ZACROS the time warp algorithm proposed by David R. Jefferson back in the mid-80s. This algorithm resolves causality violations using local operations, sending of messages and anti-messages, which encode undo actions, as well as simulation state saving and reinstating. Moreover, global operations are used to determine the progress of the simulation or terminate it, as well as delete obsolete messages and saved states to free up memory. Our benchmarks of this implementation have shown impressive speedups by more than 3 orders of magnitude for lattices with more than 1 million sites, making it possible to run simulations on systems that would be previously impossible to capture. Overall, the development of ZACROS in collaboration with the RSDG has been truly instrumental in my research. It has literally enabled simulations that were previously thought to be impossible and has allowed us to elucidate novel aspects of catalytic behavior, some of which have baffled scientists for decades. This has led to high-quality publications in peer-reviewed journals, among which Nature Materials and Nature Chemistry, but also new projects sponsored by UK, European and US funders as well as industry. ZACROS is distributed by UCL Business, having been licensed to more than 500 researchers worldwide, and I've been glad to see published studies that made use of ZACROS independently, without my involvement in these projects. I'm sure that more excellent research using Zacros will be coming up in the near future, and I thank you for the opportunity to share these developments with you at the Festival of Code.